Hey, Miss Marion here. Let's go ahead and turn to page 111, and we're going to go ahead and read the ICANN statement for lesson 4. So I can use a model to predict values for data, and I can pick out outliers on a scatter plot. So we're going to go ahead and do this. Write a sentence for each ICANN statement, and then give yourself a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it, and then 4, I can teach it to my friend. So go ahead and turn to page 33, and we're going to do our warm-up question, our starter question. It says, here's a scatter plot that shows weight and fuel efficiencies for 20 different types of cars. If a car weighs 1,750 kilograms, would you expect its fuel efficient to be closer to 22 miles per gallon or 28 miles per gallon? Go ahead and explain your reasoning. So write that underneath this on page 33. So pause, enter that, and then come back to me. So let's go ahead and let's look at this. So the trend is actually kind of going down the hill itself. So the 1,500, so if we're kind of looking at the trend, we see the information going down the hill itself. If we look at this 1,750, and we look at up kind of here, so notice how this point is almost to the 1,750. So our answer is going to be more towards 22 miles per gallon. And the reason for that is because of that's where the data is. If it would have been 28, it should be way up here, right? And is there any points up here? No, there is not. So it does not work as far as the 28 miles per gallon. So in a second, we're going to be talking about diamond and carat and diamond prices and how much they weigh. So which diamond do you think has the highest price? Which diamond do you think has the lowest price? And then 1 carat, that's how they do diamonds as far as the weight, is equivalent to 200 milligrams. So go ahead and answer those 2 questions. Pause and answer those, and then come back to me. So as far as the one that is the largest amount, it would be the one that is the bigger diamond. Okay, so the bigger the diamond, the more expensive it's going to be. So bigger diamond. Okay, and so to kind of go along with that, which one would be the least? It would be the smallest diamond. Okay, and this is actually not in your book, but we need to keep this in mind while we're going ahead and answering some questions. To also go ahead and decide how much a diamond is going to be, they look at the diamond itself, and they're going to see where it's more natural, where there's not blemishes that are in there. If there's a blemish, then it makes the amount of that carat go down, and if there's less blemishes, it makes it go up. So knowing that information, which diamond do you think has the highest price? Which diamond do you think has the lowest price? Go ahead and answer that question, and then come back to me. So the one that has the highest price is going to be the right-hand side, because notice how there's no blemishes in this diamond. Okay, so this one is going to be the highest, so the right side. And then notice how this diamond here has blemishes, has all its dark spots in there. Okay, those are naturally grown itself, but it does make it a less amount, so it's going to be the left side. So as we go ahead and go into the questions that we're going to talk about, think about the blemishes that they have in them, and then how big or small they're going to be. That will actually depend on the different prices of diamonds. All right, let's go ahead and turn to page 34 to 36. Again, we're going to be talking about diamonds and the prices along with it. So here's a table that shows the weight and price of 20 different diamonds. The scatter plot shows the price weighed of the 20 diamonds together with the graph y equals 5,520x minus 1,091. So we have a table, and then we have a graph. So the function described by the equation is model. Okay, and so it actually is modeling the relationship between the diamond's weight and its price. This model predicts the price of the diamond from its weight. These prediction prices are shown in the third column of the table. So we have the actual, so if we look at it, we have actual price itself, and then we have a prediction price for the different type of carrots. So on page 34, let's go ahead and answer the question. We're just going to do one question at a time. 2 diamonds that both weigh 1.5 carats have different prices. What are their prices? How can you see this in the table? How can you see this in the graph? Go ahead, pause, answer that question, and then come back to me. So we're looking at the 1.5 carats. So here is a 1.5 carat. So the actual price is $7,474. The predicted price is $7,189. And then the second one, the actual price is $5,904. Predicted price is $7,189. Now let's look at the in the graph itself. So we have one that is 5,904 as far as the actual price, and the other one is 7,474. Okay. Number 2, the model predicts that the one that weight is 1.5 carats, the price will be 7,189. How do you see this in the graph? How do you see it using the equation? So go ahead and answer that question and then come back to me. So looking at the graph, we have it where pretty much the point on the graph itself is going to be around here. So that amount is 7,189. With the equation, so the equation came from before, and that equation was y equals 5,520x, where x is the carat amount, minus 1,091. So what we're going to do is we're going to put the 1.5 into this equation. So we're going to say 5,520 times 1.5, let's do it this way, times 1.5 minus 1,091. Grab your calculator, and if you put it in your calculator, press enter, you're going to get 7,189. And that's that amount. And so the amount for the 1.5 carats, if you're using the equation, is 7,189. On the graph is also 7,189. Number 3, one of the diamonds weighs 1.9 carats. What does the model predict for its price? What does that compare to the actual price? So pause, answer that question, and then come back to me. So the actual price for the 1.9 carats, if we actually look at it here, is 9,397. Where does that actually come from? That actually comes from the equation. So if we did y equals 5,520 times 1.9 minus 1,091, we would get the 9,397. Now, how does this compare to the model? The model is actually the graph. So let's look at the graph itself. So on the graph, we have it as the 1.9. So 1.9 is kind of somewhere in this area, right? And so that amount is going to be around 9,500. Okay, so somewhere kind of around there, so 9,500-ish. Okay, and then how do these compare? Well, they're actually really quite close to each other. If we actually subtract the two, so we do 9,500 minus 9,397, it's only the difference on it, it's only about $103. So this actually is really good. Number 4, find the amount for which the model makes a very good prediction of the price. How can you see this in the table and then also in the graph? So go ahead, pause, answer that question, and then come back to me. So how would we actually figure this out? What we're going to do is we're going to take the table information and just kind of like how we did before, we're going to actually subtract these two and see how they actually differ. So we're going to do 4,429 minus 3,700. 429 minus 3,772. Okay, so this difference is 657. We have 4,429 minus 4,221. This is 208. We have 4,429 minus 4,032. This is 397. We have 5,385 minus 4,429. This is 956. Okay, so you kind of understand on that. So go ahead and finish that off, and then you can be able to answer the question. So as you can see, I went ahead and finished off the table, and I subtracted the two amounts to kind of see how they went ahead and differ. So what we want to do is we want to go ahead and find where the model predicts the price would be, as far as that it's only off by a tiny bit. And so let's go ahead and look at that. And so we're kind of looking at them. Okay, so there's a little bit lower. Oh, look at this 11. Look at this 46. And then there's kind of bigger in itself. So where does it, as far as the prediction and the actual price, where are they pretty much close to each other? That's here at 1.2 carats. We can also see that if we look at the graph itself and kind of showing the 1.2. See, notice how that point is actually on the graph itself. That again also shows that that's where the prediction and the model are actually pretty much the same. All right, number 5, find a diamond for which the models predict is not very close to the actual price. How can you see this in the table and graph? Go ahead and figure that out and come back to me. Pause and answer. Come back. So I'm going to actually start with the graph first. So kind of looking at from the point to the line is really what I'm looking at, and kind of seeing which one's the biggest. So from this point to that line, oh, that's kind of big. Okay. And then that's not as big as much. So really what I need to do is I need to look at 1.86, and I need to look at 1.5. And pretty much those two are the ones I want to go ahead and look at. And so I am going to look at the 1.86, well, it's 1.85. I'm going to do 9,121 minus 6,169, and that's about 952. And then I'm also looking at 1.5. So 1.5 is 7,189 minus 7,474. Well, that's the 285. Let's try the other one. 7,189 minus 5,904. That's 1,285. So where is it that the prediction versus the actual is the greatest? It would be at the second 1.5 carats. So for our next activity, we're going to go ahead and talk about feet size. So if you look at these, all of these are size 8 feet, okay? Would they wear the same type of shoe? So think about it for a second. Would they wear the same type of shoe? That answer is no. Notice how this one is a wide width. This is a normal width. And then this is a skinny width or narrow width. So all of these, they would not wear the same type of shoe. So a lot of people have to go ahead and try on shoes to make sure that they fit their feet. So just kind of keep that in mind while we go into the next scatter plot. Let's go ahead and turn to page 36 and 37. So here we have a scatter plot that shows the length and width of 20 different feet. I should have a T on it. And so we're going to go ahead and estimate the lengths of the longest foot and the shortest foot, and then we're going to estimate the widths of the longest foot and the narrowest foot. So go ahead and look at this graph and answer those questions. So let's go ahead and let's look at the longest foot. So we have this longest foot here. So the longest foot is about 32 centimeters in the length, and that actually has a width of about I don't know, about 11.9. So as far as our longest, here, let's write this out. So our longest, it's is about, I don't know, 30.25 centimeters in the length. And for the width, it's about 11.9 centimeters. For the shortest, let's change the colors so we can see that. Okay, so that's going to be probably this one here. So for the shortest, we have probably about 20.9 centimeters for the length. Okay, so that's how we decided if it was the biggest or the smallest. But for the width's going to be like 9.3 centimeters for the width. So now let's go ahead and kind of do the opposite, estimate the widths of the widest foot and the narrowest foot. So go ahead and pause and answer that, and then come back to me. So we're going to go ahead and answer this. So we're looking for the widest foot, and so the widest foot is, we're looking at the widths. And so if we look at the widths here, which it's probably going to be about this point here. So the widest has the length, so widest, let's write that down. Let's do it in red. Okay, and it has a length probably about 30.4 centimeters. And then the narrowest so in the narrowest, again, we're looking at that width. We're looking at the width part itself, so we're probably looking about somewhere around here. The narrowest has, actually the narrowest is way down here. Notice how that's around there. So the narrowest is probably going to be about 24.5. Let's change the color. So 24.5 centimeters. So here's the same scatter plot with a graph of a model for the relationship between the foot length and the width. Circle the data points that seem weird when compared to the model. The model is the line that goes through the data points. What length and width does that point represent? Okay, so let's look at it, kind of look at it and see a little bit. So pause and answer that question, and then come back to me. So the one that seems the weirdest, and as far as the information itself, is probably this one down here, right? And if we wanted to go ahead and give it a point, it's probably going to be about 24.5, comma, let's say about 7.5, okay? And why is this one weird? Well, it's off by itself. And it's not with the same data. It's not around the line. It's not with other points. It's really just kind of off. And it's off in its own little area. And this is what is considered an outlier. Meaning it's not with the rest of the data that is given to us, or it's not with the model that's given to us. It's kind of sitting out by itself. That's why it's called an outlier. So let's go ahead and let's define this. Let's turn to page 38. And in there, we have the glossary terms, outlier. So in statistics, in stat, an outlier is a data value that is way outside the group of other values. That's the mathematical definition. You can go ahead and do your own definition as far as outlier. So go ahead and pause this video and write a definition for outlier, either my mathematical one or one that you like better. So to kind of bring it all together, remember that we're looking at models. Models are where we have data points. We have this line that kind of goes in through the middle. We're also talking about scatter plots. Again, it's very self-explanatory scatter plot, that the points are scattered on the graph itself. So, and we're going to be talking more about this actually tomorrow as far as the models and predictions and different things. So that's what we were actually talking about today. Go ahead and turn back to page 111. Read the I can statements for today. I can use a model to predict values for data, and I can pick out outliers on a scatter plot. Write yourself a sentence, how you feel about today's lesson. And then give yourself a number 1 through 4. 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. Remember, we do have practice problems for today. You can find those in Canvas. And I hope you have a good day. Bye.